Welcome students. So in today's session we will be discussing the last group of instructions that is supported by the 8051 microcontroller, that is the branching instructions. So from the name itself it's clear that these instructions are used for branching or controlling the program flow of program logic. Okay, so as we discussed in the introduction class or the overview class about the instruction set, we know that the branching instructions can be of two types. One is the conditional branching, another one is the unconditional branching. So we will be initially discussing about the unconditional branching, and after that we will be moving on to the conditional branching. So the first instruction in the unconditional branching is a jump address 11. So this means a jump means absolute jump to the 11-bit address. So when this instruction is been executed, the current location, okay, from the current location the program control will be transferred to the new address location, which is mentioned by the 11-bit address specified in the instruction. Okay, so here the base, since it is an 11-bit address, the maximum possible distance to which you can transfer your program control is only 2 KB, because 2 raised to 11 you will be getting the maximum memory size as 2 KB. So from the current location to a maximum distance of 2 KB, if you need to transfer to that, but in that particular limit, I can make use of this a jump address 11. Okay, then if I need to move to the another area, if I need to extend more, that means I need to go to some location before the instruction or after the instruction, I can make use of this sjump address. So where it is a short jump, where the where on execution of this particular instruction you can transfer the program logic, okay, to a maximum distance of 256 bytes, because the address information, that is the relative address that is specified in the instruction, is a 16-bit address. So 2 raised to not a 16, it's an 8-bit address. So 2 raised to 8, that is 256. So maximum it is 256 bytes, and if I need to jump backward, the limit is from the current position I can go up to 128 bytes backward, and I can go into front of 127 bytes. Okay, so that is a feasibility if I go for this sjump address. So in this case you can see the new address to which the program execution has to be transferred is calculated by adding the adding complement to, or adding 2 to the current program counter value and the signed relative offset value that is specified as the address value. Okay, so likewise it is been calculated. So it is by using this particular format it is determining whether I need to go only to the forward condition. So if it is only to the forward condition, I can go up to 256 byte, but if I need to go backward, then this particular calculation of the address is useful for the processor, for the controller to design or decide whether it should go backward or it should go forward. Okay, then we have the L jump address, where the address specified in this instruction, that is long jump, is a 16-bit address. So the maximum possible combination is 2 raised to 16, that is 64 KB. So the maximum size of the ROM which can be interfaced with your 8051 microcontroller is 2 raised to 16, 64 KB, because we have the address lines of 16-bit for this particular controller. So the entire size, that is from the current location, it can go up to a 64 KB location, that much distance. Okay, so with that span of the current location to a 64 kilobyte, in between any of this region, in between the 64 KB to any location, I can transfer the program execution control. Okay, now basically even though it is said that even though we are using some 4 KB or 8 KB, the internal memory ROM size can be increased up to 64. Okay, now if we have an external memory address, we need to perform such external memory locations. If I need to perform a jump location where the jumping memory address is in the external memory, then I can use the instruction jump. Okay, there is no need of long jump, associate, or short jump, etc. I can just use JMP alone, and to indicate that this is a jump instruction where the jumping is between the memory locations in the external memory. I can use this pointing register, that is at the rate a plus dptr. So the 8-bit content of the accumulator and the 16-bit content of the dptr is added, and that particular content to that particular content will be jumped. Okay, so we can use this at the rate for that. Now these jump instructions are basically where you will be just transferring to that location, and we need to specify another jump instructions to return back from that particular location. It won't be coming back automatically. But in our program execution, there may be some situations where we need to perform the there is a transfer of the program logic to a new location for a specific interval of time, or for executing a specific task. Like that, when we are designing a embedded system, if there is a switch press, okay, only if there is a switch press, then a set of instructions like updating the set of the values of some 8 or 10 registers should be taking place. Okay, that is only that particular condition. So these are very rare and rarest functionalities. So to implement such type of functionalities, or sometimes we need to perform repeated calls to some of the condition like delay. Okay, whenever you're writing a delay, you need to whenever after each and every operation you need to repeatedly call this particular set of instructions. So in that cases, we call these repeated set of instructions together as subroutines or procedures. Okay, so during our program development, you will be calling them frequently, and when we call these procedures or subroutines, we need to transfer our program control to that location. We need to execute all those instructions in that location, and on successful completion of execution, we need to return back to the previous location. Okay, so for enabling those types of subroutine access or procedure calls, we have the set of instructions which is known as call instructions, and under this branching itself we are categorizing them. So we have the L call and A call. As we have seen in case of jump, L call means you can have a procedure call where the procedure is located from the current place, or is located anywhere in the room, because if you are calling that procedure from the beginning of the ROM location, the maximum size is 2 raised to 16. Okay, so in L call procedure, the procedure name or the address that you are mentioning in this particular instruction will be a 16-bit instruction, and you can have 2 raised to 16 combination, that is 64 KB, that is anywhere in the room. And we have the A call, where A call procedure name means the address that is specified along with in this instruction will be 11-bit address. So the maximum distant location at which you can place this procedure or subroutine is 2 raised to 11, that is 2 KB. So in within a 2 KB range, if you have a procedure which has to be called at a particular instant of time, then I can go for this A call procedure name or this A call instruction. Okay, now these are, till now we were discussing about the jump or call instructions which was performed on an unconditional manner, and now we need to perform on some conditional manner. Okay, so we have the first instruction, that is J is set address. So what happens is that the instruction checks whether the accumulator register value is 0 or not. If it is 0, then the address specified is added to the program counter value, current program counter value, and the new address is obtained, and to that location your program flow will be transferred. Okay, for example, if I have the program counter value 3000, okay, it is a 16-bit count, 16-bit register, so we have 3000H, and the relative address that is specified in the instruction to be some 20H. Okay, if it is a 20H or a some, let us take that 1000H, then what happens is that this J is set. Okay, if the accumulator value is 0, this 3000 plus 1000 is being added, and 4000 is a new value, and if the accumulator is 0, then your program logic will be transferred to that new memory location 4000H, and if there is an instruction at that particular memory location, it can be fetched and executed by your controller. Okay, so in order to transfer this thing only under non-zero conditions, okay, that is for if it is true, J is set address means if accumulator is 0, that is a true condition, then it is going to jump. Okay, so if I need to have a condition where it is always not 0, then I can go for the j insert address, where if the jumping of to the new location, which is created by adding the content of the program counter and the relative address, takes place only if the accumulator content is non-zero. Okay, then we have one more instruction here, that is even though it is mentioned under the branching instruction, it is not basically an instruction that is that can be classified as a branching operation, but or any, it cannot be classified under any of the basic instruction set, okay, in the instruction groups. But we are mentioning that in this case because this is going to alter the program flow by introducing some delays. Okay, that is the nope instruction. That is, it won't be performing any sort of data manipulation. It will be just implementing some small delay in your program. Okay, so the normal execution can be delayed by using this instruction nope in between your sequence of instructions in a assembly language program. Then we have the next two set of instruction, that is djne set byte comma address and cjne, where the status is been checked, and after performing the jump instruction it is been modified. So djne set means if the register specified in the instruction or the content of the memory address specified in the instruction, because we have the two format, djne set rn comma relative or djne set direct comma relative. Okay, so if the content of the register or if the content of the direct memory is non-zero, then it will be the content of this register or decrement or the direct memory will be reduced, and if it is non-zero, then only it will be jumping to the new location which is created by adding the content of program counter and the relative address. Okay, so here the content of the register or the memory location is been altered, and after the alteration it is checking whether it is non-zero or zero, then it is performing. Okay, so only if the value is non-zero, then it will be performing the jump action. Okay, so these types of instructions are used when we need to perform some repeated actions, where that is, if I need to perform a action repeatedly for 10 times, in that case I can go for this djne set. Okay, then cjne destination comma source address means it is going to compare two sources, and if they are not equal, then it is been executed. Okay, so here we have cjne a comma direct, that means the content of the accumulator and the content of the direct memory locations are compared. Okay, so they are checked for equality, and if they are not equal, then the program control flow is transferred to the new address, which is obtained by adding the program counter value and the relative address that is mentioned in the instruction. Okay, so they are just compared, so there is no updation of the values either in the accumulator register or in the direct memory location. It is just performing a comparison. So it is checking whether a is greater than the content of the direct memory, or a is less than, or a is equal to. Okay, so based on this basic comparison, the flags will be updated, and if they are equal, the zero flag will be updated. Okay, so whenever after performing this instruction, the controller checks for the status of the zero flag, and if it finds that the zero flag is not set, it means the values in the two sources, that is a value in the destination, the source, is not equal, then it performs this jumping operation. Okay, so the first case was where the two components, one of the component operand was the accumulator and the other one was in the direct memory location. We have the second variation, that is cjne a comma hash data, where one of the content is in the accumulator and other one is an immediate data specified in the instruction. Then instead of using the accumulator, I can use the registers. So we have cjne rn comma hash data, the immediate data and the content of the register rn specified in the instruction is compared, and if not equal, then jumping is activated. Then we have the indirect addressing mode here, where the content of the memory location pointed by the pointer register and the immediate data specified in the instruction is compared, and after that the jumping operation is performed if they are not equal. Okay, so these are the instructions, and apart from these instructions we do have two more instructions basically under the branching, that is return and return I, that is ret. RET and RETI, where RET means when we perform a call or L call. Okay, when we perform a call, the unconditional operations, when we perform this unconditional operations and we need to return from that procedure, that subroutine or procedure, we can use this return instruction at the end. There is no operand registers for this. Okay, and we have the RETI, that is return from interrupt. That means this subroutine or procedure is called. Okay, so these access to these subroutines or procedures are initiated as an impact of some of the interrupt that is being occurred in to the 8051 microcontroller. So after servicing that interrupt, then the program has to come back to the original position and continue execution. So in that cases, to return from the subroutine or procedure uh, that has called due to the presence of an interrupt, we use this RETI. Okay, so that are the two more instructions which is missing in the slide, but which we'll be using during the implementation of the projects. Okay, or the development of various programs in 8051. So by this we have completed the familiarization of the instruction set and the instructions in each of the functional set of 8051 microcontroller. So in the upcoming classes we will be discussing about how to write assembly language programs, and we will be developing assembly language programs to implement several objectives like addition, subtraction, multiplication, then finding largest number, finding smallest numbers, then ascending the given array, sorting the given array in ascending order or descending order, etc. Okay, thank you.